In today's note, we are going to look at our final ratio for right-angled trig, which is the cosine ratio. Again, like I mentioned in the sine ratio lesson, this lesson on the cosine ratio is going to look very familiar. And again, there's going to be slight differences, but again, it shows how similar the ratios are, and with the only difference being the sides that we use and the ratio that we're using. So again, remember, right-angled trig focuses on right-angled triangles or 90-degree triangles. There are three ratios that we could use. We've already looked at sine and tangent ratios, so we're looking today at the cosine ratio. Again, remember, in order to use right-angled trig, we need to label all three sides of the triangle, the hypotenuse, the adjacent, and the opposite. And again, this should be the first step when solving trig problems. Again, when we're labeling the sides, it's the same thing as the previous lessons, right? Hypotenuse is always across from our 90 degrees. We need our unknown or given angle to be a reference angle. Opposite is across from that reference angle, and adjacent is beside that reference angle. So again, it's labeled the same way. Again, keep in mind that if I wanted to, this theta could move down here, which would cause the opposite and the adjacent to switch spots. Right? So again, the opposite and adjacent can switch depending on where your reference angle is. The hypotenuse is always going to be across from 90 degrees. So again, just keep that in mind. When we're dealing with the cosine ratio, it is cosine theta equals adjacent over hypotenuse. So again, a different pair of sides than the previous ones, but still the same idea. Theta is still my angle. Adjacent and hypotenuse are still referring to our side lengths. So again, you can see that with sine, cos, and tan, or sin, cos, and tan, all the sides are paired up in each one, and they're all going to be different. But the fact that they're different allows us to figure out which ratios we should be using for any given triangle. Again, in this note, we're just going to focus just on the cosine ratio, so you don't have to worry about doing the wrong one. But again, we're going to go through the steps to make it helpful or useful for when we get into questions where it could be any of the three. And the first thing that we do to help us with that is identify our sides. So this one's a little bit tricky just because of the size, but we have our 75-degree angle here in the corner. We have our 90-degree angle here. So that across from the 75 degrees is the opposite. Beside it is our adjacent. And then across from our 90-degree angle is our hypotenuse. Looking at this information, the two sides that I'm dealing with are the adjacent and the hypotenuse. The adjacent I'm told that it's 11. The hypotenuse is x, which is what I'm trying to find. So those two sides need to be in my ratio. The opposite, there's no information there. I don't have a length, so I'm not concerned about what that side length is. And I'm not going to be using it in any ratio because I just don't have any information for it. So because I'm dealing with the adjacent and the hypotenuse, I'm dealing with cosine. So cosine theta equals a over h. I write out my formula, and now I plug in the information that's given. Cosine of theta, or my angle, so cosine 75, equals the adjacent, or 11, over x. Again, this should look familiar to the last two lessons, and the way we solve this when the missing piece is on the bottom is we switch the two and then divide. So that doesn't change in the cosine ratio. The only difference, again, is just what two sides we're dealing with and what ratio we're using. The operations are still going to be the same. So 11 divided by cosine 75, and we should get, when we type this into the calculator, x divided by cosine 75, we should get 42.5 as that missing length. Again, things we need to keep in mind is make sure that our calculator is in degree mode. it's not in degree mode, you will get a different answer. So again, you're looking for that D or that DEG at the top of your calculator, and if not, look for the button, the DRG, with an arrow or a triangle, and if you click on that, it should give you the option to change the mode to degree or D. Looking at the second example, again, first step as always is we want to label our sides. So across from the from the reference angle is our opposite. Across from the hypotenuse, or from the 90 degrees, is our hypotenuse, and besides or adjacent to our reference angle is our adjacent. Again, looking at what sides we have, well, in this case 14 and x, or our hypotenuse and adjacent, so that means we should be using cosine because that ratio is a over h. Write out my formula, then I'm going to plug in what I know. I know my angle is 65, adjacent I don't know, so x, and hypotenuse is 14. Again, this should look familiar when the missing piece is on the top. I bring the bottom piece up and multiply. Same as what I've done with the last ratios, but again, the only difference being in this one that it's the cosine ratio, but everything else is the same. So bring the 14 up, we get 14 times cosine 65 equals x. And this just becomes a calculation on our calculator, and we get a side length of 5.9. So the next step, I'm going to pause and let you work on the next two examples on your own. But before we do that, we are going to have today's code word. And today's code word is going to be PlayStation. So again, today's code word is PlayStation. Going back to our two examples, again, here is where I recommend that you pause and try these two on your own. Again, we've seen plenty of examples like these. It's very similar in terms of the process compared to the sine and the tangent ratio. But if you're still a little bit confused, C is going to be very similar to A, and D is going to be very similar to B. So again, write out your sides or label your sides. We're using the cosine ratio in this note, so you don't have to worry about picking the wrong one. And then just work through the process similar to the ones above it. So again, I recommend you pause the video to work on your own, and then we'll come back to these solutions. So coming back, we should see that again, we're dealing with the cosine ratio, because when we label our sides, all the given information is in our adjacent and hypotenuse. Again, we should see in C, our missing piece is on the bottom, so we have to switch and divide. So again, very similar to all the previous ones, or the exact same, as the previous ratios. In D, again, using the cosine ratio because we're given A and H, the missing piece is on the top, so that bottom piece comes up, so we bring up and multiply. Again, exact same steps as the other ratios, just different sides and a different ratio. But again, we should get 4.7 on D, and if we didn't mention it, 37.7 on C. So again, make sure you're able to get those calculations, especially using your own calculator, making sure that it's in degree mode. Moving on to finding angles, again, it's very similar, if not almost identical, to the previous ratios. We still have to use the inverse of our trig function, So in this case, we're using the inverse or cosine -1, or the inverse of cos. So to calculate our angles, if I have cosine theta equals 0.5, I move the cosine over, theta is left on its own, cosine becomes the inverse or cosine -1 of 0.5. So you're using that shift and then cosine button to get your inverse, and I get a degree of 60. Do the same thing with the next one, cosine -1 of 0.471. Just a quick calculation, and I get (61.9 degrees). And finally, for the last one, even if I have a fraction, I can still do the same thing. If you want, you could figure out the fraction beforehand, before you calculate, but I do recommend you do keep a few decimal places, at least 3 decimal places, so that you don't round too much or your answer doesn't change too much. But you should get 74.7 degrees as your angle. So again, this is just practice, making sure you can use the inverse of cosine on your calculator. Make sure you're doing it correctly. So please, even though these are simple, please make sure you can get these on your own. And then moving into the last example, same as the other lessons, we're going to go through the same process of finding an angle, but we're using a triangle to give us the information. Again, the first thing we want to do is label our sides. So across from 90 degrees is our hypotenuse. We have our reference angle, or our unknown, here. Across from that is our opposite. So beside it is our adjacent. Because we're dealing with the adjacent and the hypotenuse, we are using the cosine ratio. So cosine theta equals A over H. I'm going to fill in my information, which, same as the other examples or the other ratios, I'm always given my 2 sides. And then the last thing I have to do is the inverse of my function, or cosine -1 in this case, of 7 divided by 9. And I get, as my angle, (38.9 degrees). B is no different. The angle is just maybe rotated in a different way or orientated in a different way, but we can label our sides by going across from the 90 degrees for the hypotenuse, across from the reference angle for our opposite, and then the last side or beside our reference angle for the adjacent. Because again, we're dealing with the hypotenuse and the adjacent, we should be using our cosine ratio. I'm going to plug in my information, which when I'm looking for an angle should be the 2 sides. So I get cosine theta equals 32 over 54. To get theta by itself, I need to move the cosine over. Becomes the inverse or cosine of -1 of 32 over 54. And I get theta to equal 53.7 degrees. So again, very similar, if not identical, to all the other 2 ratios. So all the ratios, sine, cos, and tan, or sin, cos, and tan, the process, the methods to solving are all very similar, almost identical. The only thing that changes are the 2 sides that you're using. Sine uses opposite over hypotenuse. Cos, what we just learned, uses adjacent over hypotenuse. And tan uses opposite over adjacent. So you're using different sides, you're using a different ratio, but the processes are going to be the same, right? There's either that missing piece on the bottom, so you switch and divide, or the missing piece is on the top, so you bring up and you multiply. Or when you're finding an angle, you're always given the 2 sides, so you just have to use the inverse of your function, which is dependent on the ratio that you're using. whether it's the inverse of sine, the inverse of cosine, or the inverse of tan. Again, it just depends on what side you're given. So again, that's the end of the lesson, and that's all of the trig ratios.